Happy Wednesday. So we're going to start section 1.5 today, and I'm on page 83 as you can see in your book. And we have a picture of a function. We see the function itself right there, and then we see this table of values where we're trying to figure it out numerically. And as we try to approach the problem, the issue for the domain, this positive 2. So if we look at the graph, then you see we have an asymptote at 2, and we know why, because x can't be 2. So we've already talked about how this limit does not exist at 2 because it's unbounded. From the left it goes to negative infinity, and from the right it goes to positive infinity. So it doesn't exist because it's approaching those infinities. And one of the 3 reasons limits fail to exist is because they can be unbounded, which means they approach infinity. So that's all the table is showing as these x values get closer and closer to 2. Wow, what a change is happening on the y's. The x values are barely changing, even like 1.99 and 1.999, but wow, look at the y's. So we can really see that infinity idea. And the same thing on the right side. So the behavior is denoted, the limit as x approaches 2 from the left is going to negative infinity. And the limit as x approaches 2 from the right is going to positive infinity. Then that sounds confusing because I told you on the quiz the other day, I think it might have been Ava specifically asked, can I put infinity? Or maybe it was about homework, I can't quite remember. And I said, no, we have to put does not exist because it's unbounded. And if you look at the very bottom of the page on page 83, there's a caution for us right at the bottom of the page. And not a lot of attention drawn to it. So it says, be sure you see. So I'm drawing attention to it. Be sure you see that the equal sign in the statement, the limit of f of x as x equals infinity, does not mean that the limit exists. Exclamation mark. So they're trying to make a big deal out of it. On the contrary, it tells you how the limit fails to exist by denoting the unbounded behavior. And that's sort of some confusing symbols that they're using, or some confusing language, because we should say it does not exist because the limit does not exist. But by saying that it's equal to the negative infinity or the infinity, keep in mind we're telling how they fail to exist. So I feel like I should say that one more time. Right here, they are not saying that the answer to this limit problem is negative infinity. They're saying, oh, well, as x approaches 2 from the left, this goes to negative infinity. Therefore, it does not exist because it's unbounded. So it's a little confusing. Okay, continuing on with example 1. Determine the limit of each function shown in the figure below as x approaches 1 from the left and from the right. So for example A, the limit as x approaches 1 from the left of f of x. So as we approach 1 from the left, we're going up to positive infinity. The limit as x approaches 1 from the right of f of x, traveling along the graph, getting closer and closer to 1, going up to positive infinity. Since these infinities agree, we'll say that the limit as x approaches 1 of f of x goes to infinity. But we just have to remember that even though we are writing that, it does not mean the value of the limit is infinity. It doesn't mean the value of 1 is infinity. It means it doesn't exist. Why does it not exist? Because it goes to infinity. Okay, B part, we're going to find the limit as x approaches 1 from the left of this f of x. So from the left, we're going up to positive infinity. The limit as x approaches 1 from the right of f of x. Going to negative infinity. These two one-sided limits do not agree with each other. So we can't write it as this final step as the limit as x approaches 1. All we can do is talk about the one-sided limits. And keep in mind, I don't want to say it 2,000 times, but these don't exist. Saying that they equal infinity just tells how they fail to exist. I think you should go ahead and read the top of page 85. Just remember what they said about vertical asymptotes and how they talk about them. It's a little more sophisticated, maybe, than we talked about in pre-cal. And I'll start with example 2 on Thursday.